All right, so in 1.3, we're talking about collecting sample data, and I promise this is the last section that is entirely definition based. So that's kind of what we get in chapter 1 when we're just going through the basics and learning about this science of statistics. But in the next section, which is chapter 2, I promise we're going to get to the point where we're actually going to look at starting to do more than just prepare the data. So we're actually going to, start doing some mathy type things. So tons and tons more definitions in this one, but I promise this is the last time where it's entirely definition based. So first one we need to look at, and this is another one where you're, going to be classifying. So you're going to be asked, given a situation, is this an experiment or is it an observational study? So an experiment is a study where some sort of treatment is applied and its effects are observed. So perhaps I am trying out a new method of teaching and I'm applying that new method of teaching to one class and not another. And then I'm observing the effects. So what's happening as a result of this new method, for example. That's an experiment. There's some sort of treatment. An observational study is where we are just simply taking observations or measurements for a specific characteristic with no attempt to modify. So we might be, studying the prevalence of, green eyes in students at Pickerington North. We're not attempting to make more people have green eyes. We're just observing. We're trying to, record that particular specific characteristic. Other definitions. Replication. Replication is really important in the science of statistics because most often we have to work with samples because it's not always possible to study the entirety of the population. So because we're working with samples, we're working with a small group in comparison to the whole huge population. So therefore, sometimes we have to, in order to get our sample size large enough, we have the replication, which is the repetition of an experiment. So oftentimes, I might repeat the same experiment, in several different class periods, for instance. And that way, my sample size is larger because I have more people participating. Sometimes we even have replication among different researchers. So a study comes out and, they argue that their findings mean this. Well, then a different researcher says, okay, I am going to try to replicate that study and see if I really do get the same type of results that those people did. We also, within our samples, have blinding, where the subject is unaware of whether or not they are receiving the treatment. So the most common way to explain this is with medical studies. So a lot of times with a new medical treatment, they'll have the treatment itself and then they'll have a placebo, basically just a sugar pill that doesn't do anything. So if it is a blinded study, that means that everyone who's participating in the study doesn't know whether they're actually receiving the medication or whether they're receiving the placebo. A study that is double blind means not only does the subject not know whether they're receiving the treatment or which group they're in, but the experimenter doesn't know either. So the experimenter is collecting the data and they don't know which, group the subject has been assigned to. In medical studies, these are the best kind. You want it to be double blind. Now, in some sorts of studies, it's impossible to be double blind just because of the nature of what's being observed or studied. Randomization, by definition, is when subjects are assigned to groups through chance. So, you roll a dice, you flip a coin, you spin a wheel. So you're not being picked for a specific group because of a quality that you have. It's just random chance. Now, these two guys, really, really, really important that you know these definitions. These definitions are usually on either the midterm or the final. And it's difficult because they're very close to each other. Random sample, simple random sample. You are not going to have to distinguish between the two. So it's not going to ask you, is this a random sample or is this a simple random sample? You just need to know the individual definitions. You need to know the difference between the definition for random sample and the definition for simple random. So a random sample is when each element of the population, so it could be person, it could be an object, but each element of the population has a known non-zero probability of being selected. Now, notice that it doesn't say that it's equal. So it doesn't mean that one element's chance is equally likely as the others. It just means that it has a known chance of being selected. Simple random samples are a little more complicated, and that is when instead of talking about each element individually, we're talking about the samples themselves. Because if you have a population of, say, 5 objects, and we are only sampling 2 of them, there are a bunch of different possible samples of 2 that we can get from those original 5. A sample is simple random if every possible sample that we could make of size n, so in the example I just gave of size 2, if every possible sample of size 2 has an equal chance of being selected. And that's what we're talking about when we're talking about simple random. So we're talking about all the possible samples having an equal chance. A random sample is when we're talking about the individual elements having a known non-zero chance or non-zero probability. The next several, these are ones where you're going to have to be able to distinguish between them. So these samples, which are sometimes then thrown in with either random or simple random, these are types of sampling. And so they'll give you a situation, and much like the definitions in the first 2 sections, you'll have to be able to identify which of these types of sampling it is. So a systematic sampling method is when you pick a starting point and select every nth subject. So if I want, a sample of Pickerington North students, and I decide that at the beginning of 5th period, I am going to stand at the cafeteria doors and I am going to ask every 5th person who walks in that door the same question and record their answer. That's systematic. I picked a starting point beginning of fifth period, and then I selected every fifth subject that walked through the door. That's systematic. Convenient samples are when the researcher uses subjects or data that are easy to get. So instead of, standing at the door of the cafeteria and selecting every fifth, maybe I just ask all the people at my lunch table and the 2 lunch tables closest to me. That would be convenience. It's easier to do that. Those people are close to you, you likely know them better, and so that would be a convenience type of sampling. Stratified and cluster often get mixed up with each other. And the reason why they get mixed up is because both of these types of sampling involve dividing the population into groups. However, there is a very specific difference. So again, if you are a flashcard person, maybe you want to consider those, but you definitely need to make sure you do the practice problems and that you study the difference between these two. So with stratified, we're going to subdivide the population into at least 2 groups so that the subjects share 1 or more specific characteristics. Then we take a random sample from each group. Now, what kind of random sample you take, varies. But if I am dividing, the students in our class based on grade level, that's at least 2 groups. Technically we could have up to 4 groups. Normally we don't have freshmen, but we could. And so we have at least 2 groups. The subjects share a specific characteristic, so they share their grade level. If we did that with all the students in our class, stratified would mean that after we divided them into freshmen, sophomores, juniors, and seniors, we would then randomly pick, say, 3 students from each group. So all the groups are represented, and it's a specific number, and it's selected randomly. Cluster sampling, we also divide the population into groups the same way, so they have, a specific characteristic. So let's just use the same example. I divide the people in our class by grade level, but then I randomly select all the members from some of the groups. So let's just pretend that there were 24 people in our class, because 24 is a multiple of 4. That makes it easy. And so if I have 24 people in our class, and let's just say that I had 6 in each grade. Of course we don't, but we're just pretending for simplicity's sake. If I have 6 freshmen, 6 sophomores, 6 juniors, 6 seniors, stratified is where I'm going to choose 2 of each. Cluster is where I might say, I'm just now going to select all the sophomores, or all the sophomores and all the seniors. So I'm not taking individuals from every group. I'm selecting the entirety of some of the groups. So that's the difference between stratified and cluster. Again, very common for students to get those mixed up, so make sure you study them. Multi-stage sampling is when we are using a combination of the basic sampling methods. So that actually happens a lot with stratified and cluster. So we might have multi-stage in that, okay, I'm going to do stratified, and once I've divided into the 4 groups, I'm just going to, select every, second person in alphabetical order, for instance. So you could have something that's stratified and systematic, for instance, if it were multi-stage. So again, oops, make sure that you have read the section. They give really good examples, and make sure that you don't hesitate to ask me if you have further questions.